Hello everyone, welcome to this YouTube video. Today I'll be talking about the proof of the product rule. So if we have a function of f of x that's equal to some function, we can call it v of x, multiplied by another function u sub x. Now, in your first year of calculus, in this case, to differentiate f, you would use something called the product rule, which is the derivative of this first function multiplied by the second function right here plus the first function right here multiplied by the derivative of the second function. Product rule. Now this YouTube video is not to just show you this equation right here and do some example. No, we want to know how did we get this equation right here. Well, it starts all from the fundamental expression for a derivative. If we say df dx, the derivative of x derivative x is just equal to the slope formula, where we're just adding a really small, or like the smallest value we'd ever know, and we can call that h. So what we're doing right here is we're just adding h to f, actually sorry, we're plugging x plus h, and we're finding the y value for that, and then we are subtracting that from y without the h. So we're trying to differentiate this. Then we divide it by the small change in that. So it happens to be that these two cancel out, so we'll be left with h. So again, this is just a fancier version of the slope formula, which is y2 minus y1 over x2 minus x1, yes, which x2 is just equal to x plus h. So it's not a big deal. To begin our derivation now, we will plug in v of x multiplied by u of x, the product of these two functions, instead of f of x. So we write down d sub x, derivative of f with respect to the derivative of x is equal to the limit as h goes to 0 of, I'm going to make one a big one just because there's a lot of writing, v of x plus h multiplied by u sub x plus h minus v of x multiplied by u sub x. It's hard to pronounce them, but I'm trying my best. Now, we know that this right here, I did mention it earlier, f of x plus h minus f of x over h lim as h gets to 0, or limit, I should say. This expression gives us a derivative, or we can call it, since we're differentiating the function f, we can call it f prime. So this is the expression for a derivative. What we want to do is we want to use an algebraic hack to get these v and u to this formula right here. So the one thing is we have this negative sign right here, and we also have this u sub x, which means that, and you know what I can do? I can also substitute in, or no, I can just add some arbitrary value and cancel that arbitrary value by itself with the sign flipped. So for example, I just added minus a plus a, which both are going to cancel out to 0. So this expression did not change nothing. We just added these two values. And these values can actually help us algebraically. Now, what are these values exactly? So again, we want to substitute out, or we want to factor out u sub x, or we want to factor out v of x, it does not matter, so that we can get one of these function to this derivative expression right here. So we can write this down as limit. I'm going to just put a 2 dashes or 2, I don't know what they're called, but to just mean that's the same thing. Limit as h approaches to 0 of v sub x plus h multiplied by u sub x plus h minus v sub x multiplied by u sub x. So right here I can go with something like v of x plus h multiplied by u sub x, which means I can technically, for this right here, I can factor out the u sub x for these two and get this expression right here, the derivative of v, and I'll show that in a second, but I'm kind of getting way too ahead of myself, but just bear with me. So again, I need to also add the cancel, the same thing, but the sign flipped, so it cancels out, so we get v of x plus h multiplied by u sub x, all over h, of course. Now, the thing I want to do first here is I have to move these two. Well, actually, I don't have to move them both, but I can write them. And we also we can also differentiate this, u sub x right here. If we substitute out, if we factor out these, v of x plus h. So I'm going to rewrite this part right here first. So we got limit, actually, I'm trying my best to not write in cursive. So we're going to factor out, and I need to use another marker real quick, this and this. So this would just be v of x plus h parentheses u of x plus h. Another thing I can do is I can flip these two together. It would be better if I flipped these. So this would be positive right here. And I'm gonna get rid of this sign right here. I'm gonna switch that to a negative, which is exactly the same thing. So that we can get this negative u of x. So negative u of x, we're gonna close that parenthesis right here. Then, which is better because now we can also flip these, actually I can relocate these. If I move this part right here to this part, which is just basically rewriting the equation, it's not a big deal, and move this with the negative to this part right here, we would get v of x plus h multiplied by u sub x minus v of x u sub x, which I can substitute, I can factor out the u sub x. So I would write this as, u sub x parentheses v sub x plus h minus minus v sub x. I'm trying my best to say v of x or v of x. I don't know why I chose v and u, but it works. Now I can just break these two. Break this expression to 2, so we get limit as h shoots to 0 of v sub x. And here's the thing, if for this function right here, as the limit goes to 0, this would just be v of x, so we can put it outside the limit, so we can say v of x of u sub x plus h, since it's just multiplication, so it doesn't have nothing to do with the limit in general, or sorry, does not have nothing to do with the derivative. So then we can add also the second one. Use of x again does not have nothing to do with this as the limit approaches h. It's just basically going to stay the same. So use of x right here multiplied by the limit. The limit as h goes to 0 of v of x plus h minus v sub x, and I'm kind of too big. So now we wrote the derivative. Now we have these expressions as the derivative form of the function. So we're left with v of x multiplied by u prime of x plus u of x multiplied by v prime of x. Now you can just basically, and it does not look exactly like the same thing, but it just the order is different. And again, it's multiplication and addition, so you can just easily you can easily move things around without even changing the sign. So this would be v prime of x multiplied by u of x plus, this just stays the same, so you can write it as v of x multiplied by u prime of x. And that's pretty much it. So yeah, so again, this is the product rule. Thankfully we found a derivation of this way long time ago, so that we don't have to use these. And yeah, if you enjoyed this video, I might actually do the quotient rule proof. It's not that different, it's just pretty similar to this, but yeah, if you enjoyed this guys video, please drop a like, and see ya.